All right, Gary, look, I tend to say you can use some other system because, in my philosophy, I really mean that. I work and written with conservative, you know, uh, I don't know, conservative religious people that had ideas that I really did disagree with politically, but that had good character. And, but I should admit that I know you want to be scientific, right? You want to go along with science. You keep saying there are no experiments playing around with the double slit. I will. Am I supposed to shove in your face Google? It is well known. There's been more confirming experiments to the highest degree of accuracy in numbers, right? The lowest percentage of errors of any system. And they've had 100 years to try. And like these incredibly brilliant minds like Richard Feynman, you will watch his videos on YouTube. Watch his videos on YouTube. Have you done that? To me, I have nothing else that I can argue but that it looks like you're uninterested in the facts and we're not quite discussing them. And I have done everything I can to peel back, and one of the values to me is, okay, peel back the interpretations. What are the facts that really, let's say somebody just hates the description of how this thing's been solved. What do they have to deal with? And what they have to deal with is that you fire an electron at this screen one at a time, and when it's done, you end up with a wave pattern. And that's the weird thing, is like, how do you make a wave? When a wave comes at the shore of the beach, you don't get a little slice of wave just coming, and then the other ones come. It's a wave. So how do you get that particle? And assuming that the particles are waves in this other medium of the quantum field, and that field's amplitude relates to probability, makes it work out. So it's like, and then we're left with this thing of, wow, you never have just a slice of a wave come at the beach, but you could maybe take a picture, get a cross section, an MRI of the wave, and somehow we're just seeing that intersection. And that's why people talk about higher dimensional spaces. But some of the stuff you say is just, all I can do is inform you of your mistake. I mean, you say things like, how can you see the photon or something, or know how big it is? Well, I mean, how you can see it's pretty easy. It's the photoelectric effect. We notice that when light hits metallic and certain surfaces, or really all, but we could detect in some surfaces rather, that an electron is kicked off. And you can get this sensitive enough that when a photon hits, it knocks off and you get an electron count for all of the electrons that have been freed, and that tells you that something knocked it free, and you can tune it in so that it's photons one at a time. And and a similar thing with electrons, because they have a little magnetic charge, and basically that's how that works, is the magnetism and electricity involved. It gets a little harder to count things like neutrons, but they have figured out ways to do that too, and you can find that out. And the size of the wave, well, I mean, you could say we don't really know, and in a sense in the quantum field, maybe it stretches out, but it has a local space, right? I mean, we know the amplitude and the electric and magnetic fields of it. We know the distance between the troughs, the wavelength, which is really the important part, because, let's tell you, in case you didn't know, the width of the slit and the wavelength of the light are important. If the slit is narrower than the wavelength, yes, it does interfere. And that's the point, that the slit, if the slit is really big, so big that the wavelength of the light is much smaller than the slit, then the slit just passes through it, and it doesn't really affect the sides, right? So the point is, you're forcing an interaction when these things go through the slit, yes. And it's something about the interaction that causes the phenomena, yes. I mean, it's something about that. So we're not saying that, but maybe the slit interacts. No, the idea is to find out how the slit is interacting with the particle. But, I mean, how am I supposed to talk to you when I think, and okay, I'll acknowledge from your point of view, you're thinking nobody's wrong. Okay, so you would like me not to be too arrogant about it, but what am I supposed to do? Or do you want, I will get you citations if you will agree ahead of time of what kind of sources you will accept. Because, you just go, well, Richard Feynman, he does it. I mean, who's the authority? I mean, I'm not going to run and get you, it's well-known, often claimed. It's the kind of thing that could, probably be broken down. But it's certainly often claimed that that quantum mechanics is the best tested scientific theory ever. So, what am I supposed to do? There's citations of that all over. You're obviously not going to accept them. You say we can't detect the photon, and you're just making it an abstract kind of thing. We can detect photons, so what do you just seem to me like all we really know about your position is no, you don't like that quantum mechanics should be true. And I'm just saying, well, you've got the wrong ramifications. You don't really know. It's like you think there's going to be a problem, but you studied the statistics, remember? And since there's always a statistical sample, it's like it's not determinism. It's statistics, but it might as well be determinism. So everything works out great, and we've explained how. We've explained how little randomly things make regular things. And I don't see the problem. That's, and the little bit of randomness is left is usually just, well, so what? It's a lot less random than the imprecision of our eyes. So again, everything's fine. Now, it does mean we can't tell the future, but I mean, we could still try to tell the future, see how good we do, because you can tell parts of the future, and you can't tell it exact. I think that's kind of good, great. But who cares so much really about that part? To me, I feel like I'm just following what the natural evidence looks like so far after looking as close as I could to it, to what we have, with giving extra weight to physics. And I don't understand the ulterior motive, especially for somebody that wants to motivate people. So you're basically a compatibilist, and I guess I just don't get that. Why? Once I could see being a compatibilist when you believe that, that it was determined. But once you see that physics isn't determined, then why still be a compatibilist? You could just believe in free will again. And yet, you want to, you know what I mean? It's like, why do you want to not think there's a free will, even though you act like there is one? Because you say, well, no, it's not that you want, you just looked, we know, we've seen the laws. And yet, here's the laws. I don't know, could we try something calm, a class, maybe a point-by-point debate? Maybe we could practice using some debate tracking technology of, back and forth, and you ask me or structure it, or oh my God, it's Chris could structure it. So we could just go back and forth at one point, because see, there's enough details, and I know a lot of the patterns that I just want to go through the things one at a time somehow, because I could give you citations, but I already think you understand what I'm saying. I'd rather give you things that you can find citations, or you already sort of get, like you understand the law of statistics, so that's pretty much the whole story. The way samples fill in probability curves turns out to be, basic part of physics, no big deal. World's still ordinary.